Picture this, you're driving at night, and fog rolls in so thick the headlights look like they're shining into milk. Your eyes lose the road. A camera loses contrast. But some sensors keep working anyway. So here's the real question. How can one sensor see through fog, while another one creates a perfect 3D model on a clear day? The short answer is simple. Radar and LiDAR both detect objects by sending energy out and listening for what comes back, but they use totally different kinds of waves. Radar uses radio or microwave waves with wavelengths that are relatively long. LiDAR uses laser light with wavelengths that are tiny compared to radar. And that single difference, wave size, cascades into everything: range, detail, weather performance, and even what the sensor is best at measuring. Let's start with what they share. Both radar and LiDAR are active sensors. They don't wait for sunlight like a camera. They emit a signal. That signal reflects off the world, and the sensor measures the return. If you know when the pulse left and when the echo returned, you can estimate distance because the signal travels at a known speed. That's the basic idea behind everything from bats in caves to submarines using sonar, except here we're using radio waves or light. Now radar. Radar sends out radio frequency energy, often microwaves in many modern systems. Instead of a lens, radar uses an antenna, and many systems shape the beam electronically. When that energy hits an object, part of it reflects back. The radar measures the timing and strength of the return to estimate range and detect targets. But radar has a superpower that cameras don't. It can directly measure speed using the Doppler effect. If a target is moving toward or away from the radar, the frequency of the return signal shifts slightly. That shift is basically a built-in speed sensor. It's one reason radar is so good at tracking vehicles on a highway or aircraft in the sky. So why doesn't radar create a crisp 3D picture like a camera? Because radar waves are big. Compared to light, the wavelength is enormous. And in physics, resolution is tied to wavelength. Smaller wavelengths can resolve finer details. With long wavelengths, radar tends to smear small features together. It can tell something is there, how far it is, and how fast it's closing, but it might not outline every edge. Now LiDAR. LiDAR stands for light detection and ranging. It fires rapid pulses of laser light, often in the near-infrared, and measures the time it takes for each pulse to return. Do that thousands or millions of times per second across different directions, and you build a 3D point cloud like a digital dust sculpture of the world. Because the wavelength of light is tiny compared to radio waves, LiDAR can capture fine geometry, curb edges, poles, the shape of a car, even texture-like detail in the point cloud. It's incredible for mapping, robotics, and precision perception. If radar is a strong flashlight in a storm, LiDAR is a laser tape measure drawing a 3D blueprint. So which one is better? That's a lazy question. The real answer is, better at what, and in what conditions? Here's where weather shows up like an uninvited villain. Fog, rain, and snow are made of droplets and particles suspended in the air. Light, especially in the wavelengths LiDAR uses, interacts strongly with these particles. The laser pulses get scattered. Some energy bounces off the droplets before it ever reaches the object you care about. The return signal becomes noisy, or sparse, or filled with false reflections. In heavy fog or snowfall, LiDAR can lose range and confidence fast. Radar, with its longer wavelengths, tends to scatter less from small droplets. That doesn't mean radar is magical. Severe weather can still cause issues, but radar often holds up better when visibility is terrible. That's why airports, ships, and many safety systems love radar. It keeps functioning when the air looks like soup. But radar has its own weaknesses. Because radar resolution is limited, it can struggle to separate two close objects. A pedestrian near a pole might appear merged, depending on system design and distance. Radar also depends heavily on how well an object reflects radio waves. Big metal surfaces are great reflectors. Some materials, shapes, or angles might reflect poorly, making detection harder or less precise. LiDAR has a different limitation: line of sight. If an object is hidden behind another object, LiDAR can't magically bend light around it. And because LiDAR uses lasers, systems also have to consider eye safety, power limits, and cost, especially when you want high performance at long range. So in real systems, like self-driving cars, you'll often see sensor fusion. Radar gives robust detection and speed, especially in bad weather. LiDAR gives accurate geometry and shape when conditions are good. Cameras add color and texture, like recognizing a traffic light when lighting allows it. The strongest systems don't pick one sensor like it's a sports team. They combine them so one covers the other's blind spots. Here's the clean mental model. Radar is the sensor that says, something is there, it's this far away, and it's moving like this, even when the weather is ugly. LiDAR is the sensor that says, here is the exact 3D shape of the world, when the air is clear enough for light to travel cleanly. And now the fun part, if you were designing a safety system for a car that must work in snow and fog, would you bet everything on a laser, or would you build a team of sensors that back each other up? Next question for you, if you could only keep one, radar or LiDAR, what would you choose, and what environment are you designing for?